Oh my gosh, hi. How are you? I'm so excited, actually. No, I'm not really. Well, yeah, okay, kind of. It's bittersweet, guys. Like, I'm here Saturday morning. Well, actually, it's Saturday afternoon right now, but that's fine. And I'm making these videos for you. And I know that for several of you, it's going to be the last set of videos that I make for you because you're leaving on Wednesday slash Thursday slash Friday of this week, depending on whatever CTE program you're in and whatever day your capstone project starts. Those of you going on senior project, I'll probably make some more videos for you the following week, but that'll be it for you as well. I feel like we should commemorate this. I don't know with what, but you know, I feel like it should happen. Anyway, these are some videos that I'm going to make for your review that I gave you yesterday, meaning Friday. And this one is, I don't have the numbers on them because I think I like renumbered them, but this is like, if you're looking at your chapter 11 review on 11.1 through 11.5, this is like number 9. And it says, express the sum using summation notation. Use 1 as a lower limit of summation and I for the index of summation. Remember this I thing that so many of us, there we go, this I thing that so many of us have problems with, it's just a variable. So we can use X if we want to, except for the fact that directions tell us I. What you're really ultimately doing, guys, is you're trying to make this one problem look like 6, 7, and 8 on your review with the lovely summation sign. You know me, I don't make them very, very well, but that's my summation sign. And because we want I, right, as the index of summation and 1 as the lower limit of summation, that gets us started. And then the only thing you really have to do is you have to figure out what kind of an expression, algebraic expression goes there, and you have to figure out I'm sorry, I just happened to look out the window and there is a truck of, I believe, probably baseball players. Just like they're all in the truck bed just riding around in the parking lot. I'm sorry. It amused me. So you need to come up with the expression, and then you're going to need to come up with how high you actually have to go as far as, where you end up stopping, your final number that you're going to plug in there. Now, the problem is you don't know if this is geometric, you don't know if this is arithmetic, so you are trying to figure that out. Now, what you can do is, obviously, you're starting with a 3, and you have some options to get there, but the problem is you have to kind of almost think of, if I'm starting with I need to have this 1 here, right? How can I relate that to the 3? Like I could do a 1 plus 2 and I could get a 3. But then ultimately it's not really going to work. Like there are different ways that you can do it. Ultimately it's kind of a guess and a check type of deal. You can notice that maybe, you're going up by 3 in every single one of them, but that's not really, I mean, you could, like maybe if you wanted to use that, but I could also see that, they're multiples of 3. And when they're multiples of 3, guys, we tend to want to see if we can't factor out a GCF. So that first one would be a 3 times a 1. The second one would be a 3 times a 2, 3 times a 3, if it was there, which I don't know why we just didn't put it there. But anyway, 3 times 4 and a 3 times 5. And then you can see, you remember from class, hopefully, you always, you notice how each and every one of them